So here it has been told in the following cases, find the coordinates of the foot of the perpendicular drawn from the origin to this plane. So if we have a plane which is given as, suppose let's say the plane pi1, its equation is suppose ax plus by plus cz uh, plus d, that is equal to 0. Then suppose from the origin we have to draw the foot of the perpendicular. So this point M is the foot of the perpendicular which is drawn from the origin, which is 0, 0, 0. So the coordinates of this point M is we have to find. This point M will be called as the foot of the perpendicular on the plane pi1, which is drawn from the origin. So here, suppose if I assume that x1 comma y1 comma z1 is the coordinates of the foot of the perpendicular M, then we can say that since OM is perpendicular to the plane, so I can say OM will be parallel to the normal to the plane. OM will be, means OM vector is perpendicular to the plane, so I can say that OM vector is perpendicular to the normal vector to of the plane. So now here the normal vector of this plane n vector, that will be obviously ai cap plus bj cap plus ck cap. So therefore I can tell that OM vector, that will be equal to some lambda times n vector. So therefore I can tell that OM vector is nothing but x1 I cap plus y1 j cap plus z1 k cap, and that will be equal to lambda a I cap plus lambda b j cap plus lambda c k cap. So therefore I can tell x1 is lambda a x1. Therefore this point M, we can tell it is lambda a and lambda b and lambda comma lambda c. And this point also lies on the plane, so it will satisfy the equation of the plane. So therefore I can tell that lambda a times a, which is lambda a square, plus lambda b times b, that is lambda b square, plus lambda c into c, that is lambda c square, plus d, that is equal to 0. So then we can say that lambda into a square plus b square plus c square, that is equals to minus d. Then lambda will be equal to nothing but minus d by a square plus b square plus c square. So in this way you can find the value of lambda, and then we can put that, and then we can get the point M. Okay. So therefore, here also the plane equation is 5y plus 8, that is equal to 0. Then from the origin we draw one perpendicular to the plane, and the foot is point M. So now M, I can tell it is suppose x1 comma y1 comma z1, and then so OM vector will be parallel to the n vector of this plane. So the normal vector to this plane will be equal to simply 0 I cap plus 5 j cap. So it is simply 5 j cap. So therefore I can tell OM vector is equal to some lambda times n vector. So OM vector is nothing but x1 I cap plus x plus y1 j cap plus z1 k cap. So that will be equal to lambda times 5. So 5 lambda j cap. So therefore I can tell x1 equal to 0, y1 equal to 5 lambda, and z1 also equal to 0. So this point M is nothing but 0 comma 5 lambda comma 0. And this point should satisfy the equation of the plane, since this point lies on the plane itself. So therefore I will tell 5 into 5 lambda plus 8, that is equal to 0. So we will get 25 lambda, that is equal to minus 8. Then lambda will be equal to minus 8 by 25. Therefore the required foot of the perpendicular is means from the origin to the plane, from the origin to the given plane, is nothing but 0 comma 5 into minus, so from here 5 lambda we can find, which is minus 8 by 5. So it is 0 comma minus 8 by 5 comma 0. So this is the final answer. Thank you.